Welcome to myprojectbazaar.com.
Title of our product is high speed, low power and highly reliable frequency multiplier for DLL based clock generator. Now we are going to discuss about the abstract of our product. DLL based frequency multiplier produces a multiplied clock signal with the range of high frequency and wide frequency. It minimizes the delay between positive and negative edges in clock generation. It causes deterministic jitter. It achieves the high speed and high reliable operation with this appropriate structure. The DLL provides the base alignment between input clock and the output clock from the final stage of voltage controlled delay line. The proposed DLL based clock generator consists of two main parts. One is edge triggered base detector and another one is frequency multiplier. The frequency multiplier consists of pulse generation, multiplication ratio, control logic and high speed, high reliable edge combiner. The proposed edge combiner achieves a high speed and highly reliable operations using a hierarchical structure and a overlap canceller. Finally, a numerical analysis is performed to analyze and compare the performance of the proposed frequency multiplier with that of previous frequency multipliers. These frequency multipliers achieves a low power consumption by applying the relaxation oscillator block. Now we are going to discuss about the flow diagram of our product. Flow diagram of our product can be implemented by the different four modules. They are DLL system, pulse generator, multiplication ratio control logic and edge combiner. The delay locked loop system contains a voltage control delay line, phase detector, charge pump and loop filter. The reference clock is applied to the voltage control delay line and phase detector, as well as the voltage control delay line output is applied to the phase detector. The output of the phase detector is directly applied to the charge pump and loop filter. This charge pump and loop filter will be produce the multi-phase clocked output signal. This multi-phase clock signal is directly applied to the pulse generator block. The pulse generator is one of the first module of a frequency multiplier. The output of a pulse generator is directly applied to the multiplication ratio control logic. The multiplication ratio control logic contains a two multiplexer. They are produce the positive edge generation and negative edge generation. This positive and negative edge generation is fully dependent on the multiplication ratio control signal. Changing the ratio control signal to obtain the different edge generation outputs. This positive and negative edge generation output is directly applied to the high speed, high reliable edge combiner. This edge combiner contains a push-pull stage and buffer. The output of the multiplication ratio control logic will be directly applied to the push-pull stages. This push-pull stage will be produce the constrained single output from the positive and negative edge generation. The final output of the frequency multiplier will be buffered using the buffer option. This frequency multiplier is fabricated by using a 0.13 μm CMOS process technologies. It achieves a low power consumption. Now we are going to discuss about the running procedure of our product. Our product can be implemented by a Tanner EDA 13.0 version. Open the tool window to create a new file from the File menu. After the creating the files, to add the library from Add option. After adding the libraries, to create a new cell from the Cell menu. New view to create a new cell. Our product can be implemented by the different 4 cells. They are: cell 0 produce a voltage delay locked loop output, and cell 1 produce a positive and negative edge trigger, and cell 2 produce a multiplication ratio control logic, and cell 3 produce a overlap cancellation, and cell 4 will be produce the final output of the buffer. Now select the cells and start simulation process. Select cell 0 and start simulation. The output will be shown in this manner. To expand option. Vin is an input voltage, and then Vout is an output of the voltage delay locked loop output, and then V up and V down is a output of the phase detector. The phase detector is one of the block of voltage delay lock loop. Now select cell 1 to start simulate. The cell 1 will be produce the positive and negative edge triggered output. Vin is an input clock signal, and then V positive is a positive edge trigger, and V negative is a negative edge trigger output. Select cell 2 to simulate the multiplication ratio control logic. They are the output of the multiplication ratio control logic. They are differed by positive and negative output. The negative output will be denoted by the minus symbol, and then positive output will be denoted by the positive symbol. This positive and negative edge trigger output will be overlapped. This overlap will be cancelled by using the next cell. The cell 3 will be a overlap cancellation, and then cell 4 will be a final buffer output. Select cell 4 and start simulation. This is a final output of the frequency multiplier. Thank you for watching this video.